Good evening. I'm going to show you today how to do the topics that we went in class. We are doing matrices equation, right? So sometimes these might be tedious. Let's read what it says here. Ax equals b. In order to solve for x, you need to multiply by a inverse. Agree? Because we cannot divide by a. That is not allowed. So you need to multiply by a inverse by the left side or the right side, depending on where a is placed, right? So for example, in this case here, um, you can see that a is placed on the left, in the left side of the equation. So I need to multiply by a inverse from the left, right, to cancel things out. And if I multiply a inverse to the left of the equation, I need to multiply a inverse to the left on the right side of the equation. So a inverse times a gives you the identity times that vector x, and then you have a inverse times b, right? So the identity times that vector is just that vector. And then you have, as long as the dimensions they match, of course. And the inverse times b, it's the value of x in this case, right? Or the value of that vector. So let's just recall some definitions. For example, this one right here, put that in different color, or not color, the same. So if they're saying I2, that means the identity of a 2 by 2 matrix. If they say I3, that's an identity of a 3 by 3 size. All these identity matrix, they must be square. Square means the same number of columns and the same number of rows. Now, if ax equals b, it's not the same as x a times b. Why? Because here, on this equation, I'm talking about this one right here, right? If you multiply, you have to see where a is placed. So in this case, if you look at the left side of the equation, a is placed to the right. So that means that I need to multiply a inverse to the right to cancel things out. And by the same concept, to keep equivalence in the equation, I need to multiply on the right side b times a inverse from the to the right, right? Because I did to the right on the left side, I need to do to the right on the left side and the right side. They have to be the same. When you multiply them, they have to be on the same position. So sort of that, right? So when you multiply a times a inverse, that gives you the identity equals b times a inverse. So now the identity times the vector x is just that vector x, and b times a inverse is just b times a inverse, right? So you need to compute that. Just recall that ax equals b versus x times a equals b. It's not the same. Why? Because recall the commutative law does not hold for matrix multiplication. That means a times b, it's not equal to b times a. Again, a times b, it's not the same as b times a. Only in some really strange situations this might happen, right? That's the reason I put that little note in green here. I hope that this makes sense so far. Now, let's do some problems because you need practice, right? So let's do that. Let's do number one. Let's do that. Let's do that here. So here you have ax equals 2b minus c, and you need to solve for x, of course, right? Solve for x. It's just an equation. So how you do this? So you have ax equals 2b minus c. I need to solve for x. So that means I need to multiply a inverse to the left, or in the left side of the equation. So that means that this is a inverse, and you need to multiply that by the left side of the equation. So here I need to multiply on the right side to the left, of course, right? To keep that situation. Remember, matrix multiplication is not commutative. So this is what a inverse times a is just the identity times that vector x, and this is a inverse. Well, we can put the scalar here, and this is b, right? Minus a inverse c. So this is what you have so far. The identity times that vector is just that vector. So you isolate basically x. So now you need to do 2a inverse times b, right? Or 2 times, actually you should do this thing. Let me fix that. So you should do a inverse, sorry, times 2b. And then here you should do the same thing, right? A inverse times 2b, right? Minus a inverse c. Remember, because multiplication is not commutative. Now, The only problem that you have here is that you don't have A inverse, right? You need to compute that. You need to find it. So how can we do this? We need to find the A inverse. A inverse by definition is what? 1 over the determinant of A, right? Times the adjoint, right, of A. You should know that by now. Now, this is not easy, right? If I do by hand, even though it's a 2 by 2, it's still tedious or sort of that, right? So you can use your calculator to find A inverse, right? So let's use the calculator. Just give me 1 second. Let me use that. Use that. Let me see. Give me 1 second. And now let me share this with you. So at this point, you should remember how to do this, right? Yeah. So let's see. So we press enter, we clear this up, we put second matrix. Let me go back from the beginning because I didn't open it in big. So the first thing you do, second matrix, right? And now what you need to find out is what is A inverse. So you have a 2 by 2 here, you press edit, whatever you have, and you put the dimensions, which is a 2 by 2 here. And we need to calculate A inverse. So we have 2, 1, 2, 1, -5, and 0, right? That's what A was. So I need to calculate the inverse of this. So you press second, quit, second matrix. You click on that, the first one, and then you do to the power of -1, right? And that will give you the inverse. So this is the inverse. It looks ugly, so you put math, fraction, and you get your answer in fraction mode, right? So A inverse equals this, right? 0, -1 over 5, 1, 2 over 5. You should know this by now. If you don't, then watch the video that I record on how to compute this in the calculator. So now you have A inverse. So let's go back to the slide. Okay, so now we have A inverse. We computed it already. So this is 0, -1 over 5, 1, and 2/5. Now what's next? That's the question. The question is just now it's computing, right? Computing all these things. So I already solved this, but just in case, X equals A inverse. So A inverse is this guy right here, right? So we can copy, paste this, and times 2, right? 2, and B. What's B? This guy, right? Copy, paste. Let me make it a little smaller, okay? And then this is minus whatever the other thing is. So you copy this again, you get this, right? And then you multiply that by C, right? And you have that C here. So this is how you do it, right? And when you compute all this stuff, right? Here you have to do the dot product. First of all, you need to do matrix multiplication, right? You need to do all this computation, right? So when you do this computation, you get the following. Okay, so this is answer when you're computing this thing. Okay, let me copy that. So it's the same. I actually I don't need to copy that because this is the same problem, right? Yeah, so that's what I did so far, right? So I get my inverse, right? This is the inverse that I just compute, right? And then after that, I just do the dot product, and then I subtract the matrices here. So you have to do the dot product twice, right? You have to do the dot product in this part, right? Here, you need to do the dot product, and you also need to do the dot product here, and you subtract whatever you get from those 2 by 2 matrices. Remember, they have to have the same dimension, right? So remember, when you're multiplying this n times n, this is n times p, because these two, they have the same dimension, then you get as a result n by p, right? So that's basically the idea, right? They have to have the same dimension. So this is a 2 by 2, the other one is a 2 by 2. So in reality, this is this. So you get 2 by 2, right? Just common sense. And when you have when you have multiplication of two matrices that they have the same dimension and they square, well, if you have two matrices that they are square, well, what's the result? Square 2, right? That should be just common sense. The tricky part becomes when you have a square matrix with a rectangular matrix. That's when the kind of the computation gets a little bit more involved, or you might not know what the result will be. In that case, you need to apply this rule, right, that I just mentioned, this one right here. You will need to apply that. What's a rectangular matrix again? A rectangular matrix means M and N, they're not the same. They're not the same. What I mean is, like the rows and columns, like in the square matrix, the rows and columns are the same. This is a 2 by 2, right? And a rectangular matrix might be a 2 by 3. What that means? You have 2 rows, right, and 3 columns. So it could be 0, 1, 3, 1, 2, 4. So this is a rectangular matrix, right? You have 2 rows and 3 columns. That's the difference. So when you're computing all this stuff, right, you get your answer should be this thing, 3, 0, 2, -1. What I suggest you to do is do this practice, do this problem again by yourself, and try to match up what you have with what I have. Okay? And basically, I will give you this on the exam on Thursday. Some of this stuff. I'm not saying that everything is going to be this thing, but I'm going to give you some of this stuff, right? So make sure that you are aware of this and you know how to compute this. Okay, number 2. So here, number 2, they give me this situation, right? So let's compute that somewhere else. Okay, so let's do that here, just for practice. Okay, so we have here a squared equals b, right? So you need to solve for x. So a squared x equals b. So what do I need to do? I need to isolate x, right? Let me remove a little bit this thing. So what should I do? I need to multiply by the inverse of a squared, right? The inverse of a squared will cancel out with that thing. So if I do the multiplication on the left side of the equation by a squared to the -1, I need to do on the right side, multiply a squared to the -1 on the left too. So this is a squared -1 because multiplication is not commutative, right? So these two, they cancel. So this is the identity times x equals a squared inverse times b. So identity times vector x is just x, right? And then we need to compute a squared. Now, the question is, do I have a square? No, I don't. So you need to compute that first. Don't do this. Look, don't do this. This is what I'm saying. Some people, they do this thing. Don't do it. Don't do it. Oh, so this is what? 4, 1, 9, 1. If you do that, it's wrong. This doesn't hold true for matrices. Okay, that might hold for when you're doing just numbers, right? Like when we're solving equations with numbers, but for matrices, this doesn't work. So you need to do, this is equal to this. A squared equals a times a. So I need to multiply the matrix 2 times. So how I do that? Very simple, right? You should know by now how to do that. I have to use the dot product, right? The dot product. So this is a squared, right? So you multiply this thing and you get your result. So let's copy this and let's get the result here. So let's erase this stuff. So what is the dot product here? So you do it, right? Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2, right? You can sing a song about that. And then, so 2 times 2 is 4, and plus 3 and 1 is just 3. So this is 7. And this is what? The next one should be what? 2 and 81 is just 1, right? And then you do the dot product one more time. So that's 6, and 83, that's 3. And then that's 3, and positive 1, that's 4, right? So that's a squared. Let's check. Yeah, that's right. Now that you have a square, what do you need to do? You need to find the inverse of that, right? You need to find the a inverse of this matrix now, of this new matrix. So you need to find the inverse of this guy, right? So when you're doing that, you can compute that, right? With a calculator, I'm going to show you one more time, just in case you're confused, right? Because maybe you're confused with these things. Give me 1 second. Let me. So let's see. So let's do that. Actually, I don't need to do this. Okay. So let's compute this thing, right? So I show you. Okay. So let's do that. So we have, let me clear this up. So second matrix, edit, right? And I have 2 by 2. So what's the first number? It was 7. Now I need to fix it, right? 1, and then 3 and 4, right? So now you press, now that's safe, right? So I go to second quit, I put second matrix 2 by 2 to the power of -1, and that will be your A inverse, right? So again, it's ugly number, right? So we put math fraction, and you get your nice answer, right? So that will be, that's the reason I mentioned before, you don't need to do this by hand. You might get wrong answer, right? So it's better for you to do with a calculator, especially if we're doing this several times. As you can see, we're doing this many, many times. Okay, so that's your A inverse. Let's go back to the slide. Okay. So this is what we have so far. So I calculate the inverse of that A square matrix. So we move this here. So we have this guy. Actually, let's copy that. Okay, so that's the inverse, and I need to multiply by B, right? So we don't need this stuff right now. We don't need these things because we already calculated. So this is A square, and then we have the inverse of A square, just in case we need them again. And then B is this guy, right? So when you're doing your matrix multiplication, then you should get your final answer, right? When you're doing that. So the final answer for that is, I already calculated. What is that? Let's see. Here, right? So when you're doing that, your final answer should be this thing. Copy. Okay. When you're computing that, you should get that. Let's check. So when you're doing that, you're supposed to get this thing. Okay. You should get this thing. 0, 3, 4, -1. Okay. So that's here. Just in case you need the work that we did here is here, right? So that's supposed to be the answer. So this is the answer. Let me put that in yellow just in case you're still confused. This is the answer. Okay. That's the answer. Now, number 3. So number 3, they're asking you for, let's see, where is number 3? I think this is number 3. Okay, so I already solved it. So it's supposed to be this thing, right? XA, A plus identity of 2 times A. Okay, so this is the problem, and they give you just A, I think. Yeah, they just give you that. So let's copy this, and they give you A. Okay, so this is number 3. So this is 3, and let me copy that matrix that they give me. Where is that? Here. Okay, so this one, how I do this? I need to solve for X, right? So XA equals A plus identity subscript 2. Now what I need to do, I need to multiply the right side of the left, the right side of the left side of the equation by A inverse, right? So that same thing I have to do on the right side of the equation. So I need to multiply by A inverse like that. Remember, matrix multiplication does not hold for commutative property. So this is what? X, right? X times the identity. And then we have A times A inverse plus the identity of a 2 by 2 matrix times A inverse. So this is X times the identity is just the vector X. So A times A inverse gives you the identity, and this is what? Identity times the inverse of A. Do I have the inverse of A? No, I don't. So you need to compute it, right? You need to find that out, what that is. I don't know what it is. So you need to do that by hand or by the calculator. I'm not gonna show you this time how to do it by the calculator because I already showed you how to do that. I'm gonna do it in my calculator. So let me do that really fast and let me see what it is. Okay. So 2 by 2, we have 2. This is negative 1. This is 2, negative 1, negative 1, 0, right? Yeah. And then we do matrix A, and then we do the inverse of that, and we get 0, negative 1, negative 1, negative 2. So that's not too bad. Thank God. So here should be identity. You should know what it is, right? So this is identity 2. So this is identity of a 2 by 2. So this is 1, 0, 0, 1, right? And plus, okay, so we have 2 by 2. So this is 1, 0, 0, 1 times A inverse, which we already calculated right here, right? So 0, negative 1, negative 1, negative 2. So you need to add this and do this calculation, right? We have to do the dot product here, right? And we need to add it after that, right? So when you're doing that, I get this. So here is the answer, right? When you calculate A inverse, yeah. So it's the same steps, right? So we need to calculate here. Multiply A inverse to the right, A inverse to the right. So you get X here, and then you get the identity here. Did I copy? Yeah. So, So now the answer that you have to do the dot product, right? Or so you need to do you need to find out what's the identity of a 2 by 2, which you already know is this part right here, and then you need to multiply that by A inverse. A inverse is what? A inverse is the thing that we found, right? Which is this. Let's see what is A inverse in our slides. Okay, what is it here? So we have the identity, we have this number, and we need to do the dot product here, right? So we should get the same as them. Let's see, 1, 0, 0, 1. This becomes the identity, okay? Just in case you don't know what's going on. So this is the identity, and then we need to compute this, right? The identity of a 2 by 2 times the A inverse, which we already calculated. Let me double check that A inverse, just in case, to be 100% sure. One error, everything is wrong, right? 2, negative 1, negative 1, 0. Okay. Erase this. Second matrix, negative 1. Yeah, that should be right. 0, negative 1, negative 1, negative 2. Now you need to do the dot product. You can do that by hand if you want here. So this is 0, and it's supposed to be 0, right? By hand. Dot product, row 1, column 1. So this now you need to do row 1, column 2. So that's what? Negative 1 and 0, that's just negative 1. Then you do the dot product, row 2, column 1. So that's the negative 1. Row 2, column 2, that would be 0, and that would be negative 2. So now you need to compute this one more time, right? So this is addition. This is not difficult. So this is 1, negative 1. Then you have negative 1, and this is supposed to be negative 1. So this is answer, right? So that's how you do it. Let's check if they have this. Well, when I did it by myself, let's see if I get the same. I got the same, right? 181, 181, 81, 1, right? So that's the same thing. So I hope you understand this. It's not that difficult, but you have to be very careful when you're computing these matrices. Otherwise, you're going to get the wrong answer. Okay, I hope this helps and have a good night.